Good day everyone. So today we are going to discuss about rectilinear motion. So when we talk about rectilinear motion, so um, these are motion that travels on a straight line. So yung path niya is a straight line. This is a straight line motion. Kasi matanong talaga natin kung ano ba yung path niya. Then, for a rectilinear motion, it is influenced by external interferences, and it is due to the acceleration of the object. So, influenced by acceleration. Meaning, kapag may acceleration pala siya, its velocity will change from time to time. And then, for this rectilinear motion, it has two types. So, meron siyang dalawang klase. So, two types. Yung una is, syempre, yung uniform. Tinatawag natin uniform motion. So, when we say uniform rectilinear motion, from the word itself, uniform, means meron siyang bagay na hindi magbabago. So it has no acceleration. So meaning it does not affect, or it is not affected by any external interferences. At kapag sinasabi siyang hindi siya nag-accelerate, meaning it also has a constant velocity. So, meron siyang constant velocity. And if you have a constant velocity, it only means that the initial velocity mo tsaka yung final velocity mo are the same. So, ganun yung parang uniform rectilinear motion. The second type is the opposite. Tinatawag nating non-uniform. So, non-uniform rectilinear motion. And syempre, since opposite siya, so all of its definition is very different from uniform, or opposite sila. So meaning, sa non-uniform, it is, or it has acceleration, or influenced by acceleration. And not only acceleration, it also has a retarded motion. Kapag sinasabing retarded motion, meaning nag-decrease siya. In other words, it is termed as deceleration. So, deceleration. So, kapag nag-decelerate siya, meaning your final velocity would be lesser than the initial velocity. And if you have this, if you have an acceleration which influence the journey of your motion, therefore, in that case, you have also a variable velocity. So meaning yung ano mo is nagbago-bago. So you have a variable velocity. In order to visualize this concept, let's say we have here an object. So as represented by this red circle. So meron kang object, and in this manner, syempre, you need to initialize its state. Kasi sa state niya, you also need, i-describe mo siya. So, in this state, we have an initial displacement of an object. We represent that one as delta x naught for the initial displacement. Of course, meron din siyang tinatawag na initial velocity. So, we represent that one as v naught for initial velocity. And then, syempre, hindi manilimutan yung parang basis natin yung time. So, T naught. And then, in other books or most problems, they just equate this as 0 seconds, since most of the motion will start at 0 second. So, parang ina-assume na nila na ganun. So, just, for the purpose ng upload of simplicity, we just equate that the initial time is 0. Like, lahat nag-start, yung motion nag-start sa 0. Then, for this object, of course, it will travel to a straight line. Kasi diba, rectilinear motion tayo. Then, it will arrive on the next position. or maybe the final. So we can label this first position as the initial position. So it is where the object came from, and then the final position or yung destination niya. The same true with the initial position. The final position also is a state, therefore it has properties. So we have delta x lang alone for representing the final displacement, and just v alone for the final velocity, and syempre yung t for the total time of travel. And then during its journey, so itong rectilinear path na to, since we have two types, so we have here the first type that states no acceleration. So when we say no acceleration, our final velocity state is equal to the initial velocity state. Therefore, our velocity here is constant or uniform. But for the second type, yung non-uniform, our acceleration now has a value. So meron na siyang value. It's either positive, meaning nag-accelerate siya or nag-increase yung speed niya, or decelerating, yung speed niya is bumababa or bumabagal. So for acceleration, we can tell that the final velocity, of course, is not equal to the initial velocity. It could be greater than or less than. Then in order to describe these states, of course, we need some formulas or criteria. So for rectilinear motion, isa sa mga criteria dito, syempre kung ano yung notice nyo is yung velocity. So the first one is the velocity. So bakit hindi kasali yung displacement? Yung displacement kasi, class, is related to the distance and length. And then the length is already a fundamental quantity, meaning it is not a derived unit. So therefore, displacement is already a displacement. Whereas for velocity, this is a derived unit. So that's why we need to use it as our formula or criteria. So for velocity, this is just simply the rate of change of your displacement. So the rate of change of our displacement. So yun lang yung velocity natin. And in symbol, we have v equals rate of change from displacement, so delta x all over time. So ganon. This is now our formula for our velocity. You can also rewrite this as the initial displacement x naught minus final delta x lang all over t. So it's up to you. It's up to you talaga, class. Then we also have another criteria for this motion. We have acceleration. So meron din tayong acceleration. Since this is the main factor that influence our motion, kung bakit yung velocity niya is humihina or lumalakas. So ganun. So for acceleration, it refers to or measures the rate of change of the velocity. Kasi yung velocity is the rate of change of displacement, then it follows din na yung acceleration is the rate of change of that velocity. So in symbol pala, class, our acceleration is represented by a, which is equal to the change in velocity all over time. Then the change of velocity is just simply the difference between the final velocity minus the initial velocity all over time. So take note of this one. This is our formula for the acceleration. So binabakso talaga to para ma-take note nyo. And then class, or siguro may nagtatanong sa inyo, sir, ano pa, sir? So we have the third criteria or formula. So for the third criterion formula, it is not actually, or it cannot be derived easily by looking at the figure. Kasi 'di ba, for the velocity and saka acceleration, meron na kasi tayong ditong background mga rate and change lang to. Pero yung third formula natin is this is derived from the concept that the velocity is variable along the journey if it has acceleration. So therefore, we don't have any exact value of the velocity for each position and for each time being. So therefore, meron lang tayong standard na we just take the average velocity. Then, ito na yung equation number 3 natin. So, yung average velocity pala yung nadagdag. So, we have average velocity. So, it is not the same with our velocity alone. Kasi yung average velocity states that it is the ratio pala of the total distance traveled. So, yung total distance na na-traveled mo all over yung syempre, since velocity meron kang time, so total din, yung total time of travel. So, ganun yung parang average velocity mo. Then, if we are going to write this into an equation, so we have V average. So, V average is equal to total distance traveled is just simply delta x. So, yung sum of the displacement all over total time. And remember, your statistics subjects or mathematics subjects, we all know that the average of a number is just, let's say, if the numbers are 4 in all or 5. So, if ever there are 10 problems, so let's say tatlong number lang, I mean. So, sa tatlong number, the average is the sum of the 3 numbers divided by 3. For 4 numbers, the sum of 4 numbers divided by 4. So, therefore pala, in our case here, for our motion, we only have initial and final state. So, we only have 2 velocities. So, we just say that we add the initial and final velocity divided by 2. So, yun lang. This is now the formula that you should remember in order to derive those kinematics equation. So, ito pala, so from the three equations or from the 3 criteria you can derive the 5 kinematic 5 or 6 or 4 5 kinematic equation used to describe the rectilinear motion. And then bakit hindi lang yung tatlo yung tatandaan natin? Bakit meron ba tayong 5 kinematic equation? Kasi in the 5 kinematic equation, it is ano na siya, simple na siya, and then it is already accustomed ba or fitable for those problems that does not have any given for other variables, like they're only given to a limited type of variable. Still, we can solve the problem then by using this kinematic equation. So let's start first kung paano ba na-derive yung kinematic equation natin. So let's say we have here our first, so yan natin na ito yung first kinematic equation natin. So our first kinematic equation. So, kinematic equation. Ayan na. Then, for the first kinematic equation, of course, from the acceleration, equation, we all know that A is equal to delta V all over T, which is equal to the final velocity minus initial velocity all over time. And by having a cross multiplication for numerator denominator, then numerator of the denominator for A and v minus v of t all over v naught all over t alone. So we have here, so let's cross multiply a times t, so we have at, which is equal to, so 80 to ha, so this is 80, which is equals to v minus v naught. Let's try, or let's assume na yung equation natin is a function of the final velocity. So final velocity is here, therefore we need to transpose this initial velocity on the left side. So we now have our final velocity is equals to the initial velocity plus the product of acceleration times time. So ito yung first kinematic equation natin. Final velocity equals the initial velocity plus acceleration times time. So next, let's proceed to the second. So meron tayong second kinematic equation. So diba, from kinematic equation number 1, the displacement is not given there, but you can still solve the problem whenever there is a variable that lacks there and you have 3 variables that are given, so you can still solve the missing variable. So for the second kinematic equation, we all know that from average velocity, so from average velocity equation, we have delta x all over t is equal to the final velocity plus initial velocity all over 2. Then take cross multiplication, so 2 delta x is equals to v final plus v initial times the time. Then in this equation, we all know that from first kinematic equation, so from first kinematic equation, we all know that v is equals to v naught plus at. So itong final velocity natin is yun lang yung idagdag natin dito, so just substitute it here. So therefore magiging ano na to, 2 delta x is equals to v naught plus v naught plus 80 times time. So may time ka na. Then what will you do next? Of course, you need to divide both sides by 1/2, so that the displacement alone will be left on the left side. So we have delta x is equals to 1/2 times twice VO, kasi VO plus VO to VO, plus 80 times the time. Then distribute 1/2 and t. So we now have delta x is equals to v naught t plus 1/2 a t squared. So ito lang pala yung second na kinematic equation. Then we also have the next one, so yung third. So yung third kinematic equation. So from our third kinematic equation, so from first, medyo ano na to yung third kinematic equation, dami na niyang mga ano dito, assumption. So let's say, oh I'm sorry, medyo na long press siya. Erase natin. Okay, thank you, na-erase na siya. So pasensya dun class ha. Continue pa rin. Okay. Medyo na ano lang pala siya. So let's erase first para hindi magulo sa mata nyo. So for our third kinematic equation, natin na from the first kinematic na equation, we all know that t is equals to v minus v naught over a. So parang diniderive na natin. So why we choose this t? Because from the first and second kinematic equation, meron pa tayong time na variable. So for now naman, let's find a way on how to get rid of the time. So i-eliminate natin ang time para meron tayong kinematic equation na hindi nag-involve ng time. So ganito to. So then substitute this t, or plug this t to the to second kinematic equation. So kinematic equation. So i-substitute mo lang tong t dito. So on the second kinematic equation, we have delta x is equals to v naught t man. So yung t natin is v minus v naught over a plus 1/2 a times v minus v naught all over a squared. So therefore, ito pala is okay, in order to simplify those things na lang, let's just multiply ahead. So just multiply ahead by, para makancel tong a dito, so I will multiply a, and then para makancel yung 2 dito, I will also multiply 2. So let's multiply both sides by 2a. So distribute. So we have 2a delta x, which is equals to, makakancel na yung a, so we now have 2v naught v minus 2v naught squared. Then plus, since 2 times 1/2 is 1, and then a times a squared, then squared pa din yung bottom, so makakancel na class, diba? Okay, so let's just put this way na lang. So a squared times v squared minus 2v v naught plus v naught squared all over a squared. Diba, as you can see, may a squared dito, may a squared, so therefore this will be cancelled out. So what's left is 2v naught v minus 2v naught squared plus v squared, final plus t squared, minus 2v v naught plus v naught squared. So we have a positive 2v v naught here, a negative 2v v naught, therefore this can be cancelled out. So mas 0 na to sila dalawa. So what's left is, we have square of the v final minus, so meron tayong minus negative 2v naught squared plus v naught squared, so we have minus v naught squared. Then so on the left side, we have 2a delta x, and since we want to know the third kinematic equation as a function of the final velocity, so we have v phi squared. So i-transpose mo lang to doon sa kabila, so we have v naught squared plus 2a delta x. So ito na yung magiging kinematic equation mo. So ulitin natin para makikita talaga. VO plus 2a delta x. So ito lang talaga yung third kinematic equation mo. Then how about for the fourth kinematic equation? Because there are some books that they have the fourth kinematic equation, but actually yung fourth kinematic equation lang natin, it's just, so let's write the fourth, number 4. So we have the fourth kinematic equation. So kinematic equation, actually yung fourth kinematic equation kasi is just the yung parang walang wala acceleration. So it's just the same as the average velocity. So we have v average is equal to the total displacement over total time, which is equals to the final plus initial all over 2. So if rearranging these terms as a function of displacement, so we have delta x equals to v plus v naught times the time, then multiply both sides by 1/2. So multiply natin both sides by 1/2, so we have delta x na lang. So we have delta x equals to 1/2 the final plus initial velocity times your time. So this is now our fourth kinematic equation. So from the fourth kinematic equation, we can tell directly, like for the first, di ba alam natin sa for the first na the final velocity is just equal to the initial velocity plus acceleration times the time. So ano ba yung locking dito? So yung locking natin, lock siya ng anong lock niya? Lock siya ng displacement. So displacement delta x. How about for the second kinematic equation? So for the second, we have delta x is equals to v naught t plus 1/2 a t squared. So yung locking dito na variable is, so anong ko lang dito, we don't have any final velocity. So final velocity yung wala, final velocity. Then for the for the third kinematic, that is the square of the final velocity is equals to the square of the initial velocity plus 2a delta x. So in this, yung locking dito is, of course, obvious na, is the time. So time is in seconds or abbreviated as t. Then for the fourth, so for the fourth kinematic equation, we have this one. Delta x is equals to 1/2 times v plus v naught times t. So yung locking dito is, yung locking natin dito is acceleration. So acceleration, acceleration A. So parang ganun lang. And I think you are already ready to answer some basic problems. So ito lang talaga yung tatandaan nyo, class, itong kinematic equation, and you can derive those one using the D3. So use the acceleration. So yun ang kasap, ulit-ulit talaga to, and then use the average velocity, to talaga, and then simply the velocity para ma-derive yan. So yan tatlo na yan nagpapaderive sa apat na kinematic equation. So okay, so let's start now some problems. Let's say we have problem 1. An object is moving at a constant speed of 3 meters per second for 10 seconds. Afterward, it slows down by 5 meters per square second and stops. Calculate the total distance traveled by the object. So to to attack a certain problem the right way, so we need to have an illustration first. So let's say we have to illustrate. So illustration. So ano yung shape tsaka forma pala ng ng problem. So dito natin malalaman. Sabi na an object is moving. So let's say an object is represented by this red circle. Red solid circle. So an object is moving at a constant speed. Meron pa ito siyang speed na 3 meter per second for 10 seconds. So sabi na dito constant speed. Pag sinasabing constant speed, this is a uniform motion. Type 1. So uniform motion, meaning we don't have any acceleration. So nag-constant speed siya for 10 seconds. So dito, so for 10 seconds lang. So hindi natin alam kung ano ba sunod sa 4 seconds. So this one, the t here is equal to 4 seconds. I mean 10 seconds. So meron time dito. Then of course, since constant, yung velocity dito is just 3 meters per second again. Then, sabi dito, afterwards, it slows down by 5 meter per square second. So, therefore, it decelerates by that magnitude. So, hina siya and stops. So, dito siya huminto. So, meaning we have 3 positions. So, we just label here as position 1. Then, we have position 2. And then, position 3. So, ganun lang. So, along this journey, so ito na yung non-uniform. So, non-uniform na dito. Non-uniform na journey. So, here we have an acceleration of negative 5 meter per second square. So, it decelerates. And then, kung i-ano natin yung given, so, given, so, yan yung mga given natin. So, given. We have your given. We have, first one is the V1 or the initial velocity. So, our initial velocity is 3 meter per second. Then, our V2, so our V2 is the same as the initial velocity since it travels at a constant speed, which is equal to 3 meters per second. Then for our V3, so V3, since it stops, therefore wala na siyang movement or wala na siyang velocity, therefore V3 is just 0 meter per second. So 0 siya. And then of course we have acceleration. So A is equals to negative 5 meter per second square. So if you have a different units on the other variables, you can change now. So it's up to you. Or if i-convert mo para ma-combine na siya sa other na mga variables. So for this, okay, take note, we also have a temperature during the constant process, which is equal to 10 seconds. So for this, paano natin to i-ano? Kasi dyan sa dyan sa second na part, we want to know, or okay, let's put the required. Sorry, ito pala is yung susulatin natin para sa requirements. So required, or dito na lang. So ano ba yung mga required dito para sa problem na to? Okay, so we have displacement. So delta x total displacement, meaning meron siyang displacement sa displacement at constant speed, di ba? Constant speed plus displacement niya before it stops. So yan yung displacement niya, yung nag-decelerate na siya. So for the displacement, so ito na yung magiging solution natin. So we have our solution. So solution, ganun. So for our para sa ating solution, since we don't have delta x, and then since we have initial velocity for the non-uniform, which is v3, and then we also have a final velocity which is 0 kasi nag-stop na siya, and then meron din pa tayong acceleration, so therefore pwede na natin makuha yung delta x para dito. But before that, let's just solve for the delta x at constant speed. So constant niya, constant speed. So we have delta x is just velocity times time, and then we all know that the velocity is 3 meters per second multiplied by 10 seconds. So therefore, yung displacement mo dito during constant speed, delta x at constant speed is equals to 30 meters. O, diba? 30 meters. How about delta x at non-uniform motion? So delta x, pasensya, medyo na siya. Okay, so we have delta x equals, or delta x at non-uniform. So meron na siyang acceleration. So yan, non-uniform at non-uniform. So ano ba tong delta x at non-uniform? So you can use the second kinematic equation, in which it states, or even third na lang. Kasi if you're going to use the second kinematic equation, wala siyang t, lacking yung problem ng t, so therefore you cannot solve that one. But you can apply the third kinematic equation by this formula. The final velocity squared is just equal to the initial velocity squared plus 2a change in x. So meaning meron tayong change in x dito, meron tayong a, which is given, equal to negative 5 meter per second square, and an initial velocity which equals to v3. So meron din, meron tayong final which is 0. So substitute natin. For the final, we have 0 equals for the initial, since v2 is equals to v1 at constant speed, so yung v0 natin is 3 meters. So 3 meters per second squared plus 2 times, take note for a, negative 5, so lagay mo negative 5, then delta x. So simplify, we have 0 equals 9 minus 5 times 2 equals 10 delta x. Then we have delta x, rearranging, we have 9 over 10, which is approximately equal to, so magkano ba ito? 9 over 10, 0.9, diba? So this is 0.9. It's not approximate because it is really equal to 0.9 meters. So therefore class, I mean, andito naman siya. So napindot kasi yung ano. So therefore, babalik natin na. So therefore pala, yung total displacement natin, so total displacement is just delta x total is equals to delta x at constant speed plus delta x dun sa non-uniform. So we have 30 meters plus 0.9 meters. So we have, pasensya na, ito ay 30. So we have 30.9 meters. So ito yung total displacement natin para sa problem na ito. So 30.9 meters lang pala. Then let's jump to the second problem. So we have here, sabi dito, how long does it take an automobile traveling in the left lane of a highway at 60 kilometers per hour to overtake or become even with another car that is traveling in the right lane at 40 km per hour when the car's front bumpers are initially 100 meters apart? So for this question, it would be very best if you illustrate. So illustrate natin, ha. Illustrate natin, guys. Una-una illustrate. So ito na yung illustration natin. So illustration, and you can have also the given, since important din yung may given. So to illustrate this, sabi daw initially, so we have initially ito yung parang, okay, pasensya na, ito yung parang nangyari niya at first. So we have here a car on the right lane, or ano, baguhin natin para medyo malaki siya. Release mo natin yung given. Let's say we have a car on the left. So meron car on the left, then yung velocity niya is at 60 kph. Then we also have a another car na medyo ahead na sa kanya. So ahead na on the right lane. So left siya, right lane, traveling at 40 only, 40 kph. So from these two cars, there is a possibility that the 60 kph will overtake 40 kilometers per hour. And then the relative distance for two is 100 meters. Sa ano pa yan at initial point of time. Then for the final, so yung final state na, sabi niya overtake. So overtake. So kailan daw maka-overtake yung car that is found on the left? So on the final state, so i-mark X lang natin to. So i-mark X lang natin yung ano, dito na naman. So let's erase this. So let's erase. Let's say ito yung initial point ng 60 kilometers per hour mo, and then ito din yung initial point ng 40 kph mo. Then dahil nagmo-move yung dalawa, so dito na yung 40 kph. So ito yung 40 kph. But since na overtake ka na si 40 kph, so the same na pala yung position nila sa 60. So they are both the same. So this is 60 kph. So yung total distance pa ng 60 kph is 100 plus kung ano yung na-travel ni 40 kph. Kasi yung kay 40 kph lang is just x. So yun lang yung na-travel niya. Then ano ba yung given? So yun yung pag-illustrate. Siyempre dapat alamin din natin yung given. So what are the given here? So let's try let's have 60 kph. This is for speed of the left na vehicle. So ganun. Then we also have 40 km per hour, another speed of a right vehicle. So meron silang ganun. And then we also have 100 meters. So meters to. Then ito pala yung distance nila. So distance between them. And since hindi pa to siya kilometer, since very tayo dapat magko-conform tayo sa units. So 100 meters is just equal to 0.1 kilometers. So therefore this given pala written as 0.1 kilometers. So yung required natin, is time. So yung oras pala, the time that should be consumed in order to overtake. So time of overtake. So tingnan natin kung naka-overtake or naka-overtake talaga siya kasi yung time lang talaga. So let's see. So now we have a solution. So solution tayo. Okay. We base our solution to the final state, since in the final state there's a variable there na x, and then it is also a gateway on how to solve the total time, kasi sa final state naman natin malalaman yung total time. So in the final state, we can say that the velocity of 60 kph, or okay, let's erase this one. The velocity of 60 kph is equals to 100 plus x all over t. And then we also know that the velocity of 40 kph is just equal to x over t. So since meron tayong x dito sa second equation, so we can plug this one here, diba? So we can write this as x is equals to v40 kph times the theta. So here is a substitute mo, so we have 100 plus v40 kph times time over time. Then cross multiply, we have 100 plus v40 kph times time, which is equals to v60 kph times time square times time lang. So combine those terms that involves the variable t, so yung time. So we have here t times v60 kph minus v40 kph. Then so ito yung t natin, ha, at t times this is equals to 100. Then divide the two terms by v60, so we have 100 divided by v60 kph minus v40 kph. So yung resulting answer niya is so 100, I mean it's not 100, it's already 0.1. So, dapat naka-meters tayo. So this one here pala, and this one right here is must be equal to 0.1 kilometers. Kasi kph din yung mga velocities natin sa ibaba, and then in hours. So therefore yung time natin expect na this is in hours. So we have 0.1 divided by 60 minus 40. So we have a time of 0.005 hour. So if we're going to convert that one in seconds, so we have t is equals to times 1600. So you have t is equals to 18 seconds. So ganun lang, ito yung parang final sagot niya. T is equals to 18 seconds since 1 hour is equivalent to 2,600 seconds. So ito lang, like maano agad niya. Kasi diba yung 100 meter pala is 100 kilometer. So I think it is already explained clearly. So medyo na-clear naman yung pagka-explain, kaya like alam nyo na agad. So therefore at 18 seconds pala ma-overtake ka na pala ng yun, ma-overtake ka na siya ng car B na may speed na 60 kilometers an hour. So ganun. So yeah, yun na nga, in just 18 seconds, so maabutan na niya kasi 100 meters apart, then 60 kph. So ganun siya. Then next, we have here the next one. So punta tayo sa last part. So we have the last problem. So sorry, meron talaga ako ng sipon. So we have here, what is the minimum initial velocity required by a golf player to move the golf ball at 0.5 meter per second square from a distance 1 meter towards the golf hole? Assume that the golf ball travels in a straight line towards the golf hole. So again, don't forget to illustrate. So we have an illustration. So illustrate na tayo. So illustration. So here, sabi na dito, minimum initial velocity required by the golf player to move the golf ball. So meaning, meron tayong bola dito. Then parang hampasin siya yung parang sa sa golf. So ang ganon. Tapos mag-move daw to siya patungo dito sa hole. So parang yun yung parang goal niya. So dito, and then yung movement pala niya pa doon is meron siyang acceleration. So its acceleration is 0.5 meter per second square. And then yung distance pa dito, sabi niya from a distance 1 meter towards the golf hole. So ito, golf hole na to. So golf hole. And then its distance from the object is 1 meter na lang. So meaning meron na siyang 1 meter para ma-complete yung golf track. So yung hinahanap, here, di ba, na-shoot kasi siya sa golf hole, therefore yung velocity mo dito, let's say this is final and here is initial. So yung final velocity mo is ano yung final velocity niya? 0. So, kasi kapag yung final velocity mo has a value, therefore your initial velocity is maybe greater than. But here it states that the minimum initial velocity So therefore, yung minimum initial velocity lang pala is masatisfy niya kapag nakashoot na yung bola sa golf hole location, yung velocity mo na doon is 0 kasi nag-stop ka na. Kasi kapag hindi pa yan 0, meaning it just keep on doing, although it will be catched by the hole, but it's not the minimum initial velocity. Mas ano yung minimum initial velocity kasi medyo konti lang yung force na i-exert mo in order to move this object. Konti lang. So let's write the required. So kasi most of the given was already there on the figure, so required. Sabi dito, what minimum initial velocity? So required niya is the minimum initial velocity. Initial velocity. Then we have solution. So let's solve. So here we have i-displacement 1 meter. So itay natin na meron pala tayong displacement dito. So we have delta x equals to 1 meter. So ganon. So meron tayong displacement. So anong gagawin natin dito? Meron tayong displacement na 1 meter, meron tayong acceleration na 0.5 meter squared. We have a 0 final velocity, and we need to find the initial. Therefore we can use, kasi walang time dito time is not stated, so solution, we use the third kinematic equation. So dapat nyo talagang tatandaan para malaman nyo kung ano yung the proper formula to be used for that particular problem. So for the third kinematic equation, we have v final squared is equals to v initial squared plus 2g delta x. So diba ganun? Then of course we need to find v naught t. So therefore yung ano pala, okay, sorry for that one, noisy siya. Sensya na. So for this one, okay, let's have a division. So we have getting the initial velocity. So we have v naught t, v naught squared is equals to v squared plus 2g change in x. I mean this one pala is minus, diba? Since it stops na, so since it stops already, so our final velocity is equals to 0. Therefore magiging 0 din to siya, 0. So we now already have v naught squared equals to negative 2a delta x. It's not g pala, it's a. This a, and also this is a because g is used in free fall. So v squared is equals to negative 2a change in x. So based on this, if we say it accelerates, then it doesn't have any solution because this one when racing to 1/2, it is undefined or indeterminate. So therefore yung a pala natin dito is deceleration. So deceleration, ibig sabihin hindi siya pwede na mag-accelerate kasi kapag mag-accelerate na siya, meaning yung final velocity mo is meron talaga siyang chance na hindi siya mag-0. So therefore you have v naught is equal to the square root of negative 2 times negative 0.5 times yung change in x natin, so 1 meter. Ganun. So therefore we have a initial velocity of the square root of 2 times negative 0.5 times 1 times 1. So we have an initial velocity of 1 meter per second. So lagyan mo dito 1 meter per second. So ito lang pala yung minimum na initial velocity na required mo para dito na problem. So in this topic class, be sure to know those kinematic equations and the fundamental principles applied in the rectilinear motion. These are the acceleration, velocity, and the average velocity. And from that out from the three equations, you can derive the first up to the fourth kinematic equation. So class, thank you for listening, and God bless.